So we all should have made our Perceptron file for the breast cancer data. So that was a lot of the hard work. All we really need to do is make copies of it and slightly adjust it for the other learners and then see which one performed the best. And I'm going to show you that we're going to create a pretty good breast cancer predictor just from this code, which is phenomenal. Like people sell this kind of stuff for thousands and thousands of dollars to help doctors. So what we're going to do, let's just click on, you see results? That was a file created from when we ran our Perceptron program. And so what it has is it shows, okay, we ran the Perceptron. The best parameter we have is that. And then the total of the day we got was about 77 total percentage, okay? Because it did 86% on the test, but only 73% on the training data. All right, so now all we had to do, we're going to do the last 6 learners, and it's very easy. Watch, you just click on it, and we're going to duplicate. And so we'll go into it. Close that. Again, all we got to do first. So we're gonna do specific order. We're gonna do we're gonna do the SVM linear. We're gonna do all the linear ones first, and then we're gonna do all of the ones that use curvy lines, and then we'll do the trees like the decision tree and the random forest. So let me stop my sync real quick so it doesn't keep interrupting us. There we go. Okay, so stop it. All right, let's just say we're doing this on Tuesday, the 26th. All right, so the only thing we have all the same data. We know we've done everything we need to do. All we really need, the reason we created this little label is it says where to change for a different type of learner. Okay, so this time what we're going to do is we are going to change it to the SVM linear. Okay, so we're just going to type SVM and then linear. And the parameter name is C, okay? That's what it is. So let's try, for the parameter name, let's try all of these. Let's not try, we don't need 100,000. Let's try all of those. And we don't need to change any of this stuff. This stuff is all good. And let's change, we need to change the word perceptron to SVM linear. Okay, oops, not all caps. There we go. All right, and then everything else after that should be the same. Okay, so we're going to run it. We're going to go kernel, restart and run all, and let's see if it works as it should. So let's see what's happening right here. So it's going through, it did the data, awesome. Okay, so it found, uh-oh, we have an error. And the error is because I made this all caps. Bad move, bad move. Alright, it's supposed to be lowercase. There we go. Restart and run all. So that one I kind of did on purpose just to show you guys, hey, capitalization still matters, okay? And if you get an error, it's probably a capitalization thing. So let's see. Alright, so, ooh, the best parameter was 10, it looks like. Interesting, interesting. And again, uh-oh, SVM capital linear. Nope, we want a lowercase. Okay, so restart and run all. Those are just 2 little examples, because those are the 2 places you'll probably mess up the most. Alright, again, it came out as 10. Good. Create a learner. Ooh, it calculated fast. So the highest it could get on the testing data was 82%. Let's see how it does. Okay, so it looks like, okay, training data got a 73. That's the confusion matrix. Okay, so 32 got right for healthy, 27 it got right for cancerous. And let's see, so it got an 83 on the test. And so look, it just printed out, this is how it did on the test. Okay, so it got, 1, 2, 3, 4, 5, 6 wrong. So overall it got a 76, okay, which is a little worse than our Perceptron. But that's how easy it is to apply a new learner based on what we just wrote. So we already did the hard work. So watch this. We can just save that. If you exit out of the results. Now watch, when we pull up the results, it looks like the linear one got a 76. So that was a little worse than the Perceptron. All right, let's do another learner. We're going to duplicate it. Let's do the other one that uses straight lines. So that's the logistic regression one. So again, all you do is let's change the name first. So we're going to do logistic regression. And get rid of this copy thing. Alright, so let's see. Okay, we only need to go down here, and we just need to change this to logistic regression. It luckily has the same type of parameter, the C parameter, so we're going to leave it all like that. And then we just need to change this to logistic regression. Okay, let's run it. See what we got. Alright, ooh, that was fast. Let's see what parameter it found was the best for it. Oh, so it found 10 was the best for the logistic regression as well. It ran it. Ooh, here's how it does. So it looked like only 5 were really that important because it takes the the greatest one. So BMI, glucose, insulin, resistant, and NCP.1 were the most important columns. So nice. Let's see. It scored a 75 on the training data. Okay, that was its confusion matrix. It scored an 83 on the testing data. And so overall, this looks like maybe one of our best ones. Yeah, 78. Pretty good, not bad. Not bad. Watch, now we can exit out. Oops. Make sure to save it. Alright, remember you have to exit out of that, and then if you want to look at it, be like, yeah, let's see how it says. Okay, 78. Not bad. Okay, so now let's do the curvy ones. The ones that use the curvy lines. So we're gonna hit duplicate. Alrighty. We're gonna do the SVM kernel, how about? Okay, so we'll rename this SVM kernel. We can get rid of this, we don't need that. All we need to do is go down here and change this guy to SVM kernel. And then it uses the same parameter C. Let's try the same numbers again, and we need to change this from SVM linear to SVM kernel. All right. Let's run this. Uh-oh, we got something wrong. What did we do? Let's find out. So, it said incorrect type. Oops, again, I did it wrong. This needs to be lowercase. SVM kernel. Yep. Classic mistake. Classic. Okay. Oh, let's check out what happened. So it found the best parameter was 100. Interesting. Okay. And then it went through all the data. It found, okay, the highest it could get to on the testing data was 82%. And it found, it looks like 5 of them, again, age, glucose, insulin, restin, and NCP.1 were the most important. On the training data, it only missed 1. Nice. And on the testing, it missed 6 and got an 83. So look, this is the confusion matrix, right? So it only missed 1 of the cancer diet. It incorrectly classified one of the cancer people as healthy. Interesting. That's pretty good. So look, this is how it did on the test. It missed 6. I think that's what it said, right? Yeah, 6. So these were the 6 it missed. It missed that one, that one, that one, that one, that one, that one. And then overall 94. Not bad, not bad. Okay. So let's save it. Exit. Now let's do the we're going to duplicate this, and we're going to do the k-nearest neighbor. Alright, so again, we just need to change our title. We're going to change it to k-nearest neighbor, KNN. And then all we had to do is scroll down to, and let's change this guy to KNN. And then I think, let me check my notes. The parameter name, yes, is n neighbors. That's how you spell it. And so this is like how many neighbors it's going to test. So let's do 1, 3, 5, 7, 9, 11. And then we need to change this guy down to k-nearest neighbor. So now we're going to create the k-nearest neighbor learner. Let's run this. Let's see how we do. Dun, 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 dun. Give your partner a high five if you guys are doing well. Alright, so let's check out how I did. So it found out the best it could do nearest neighbor of 1. Interesting, okay. So the max score it could get on the training data was an 82. It looked like only 3 of them were deemed the most important for the k-nearest neighbor: the age, the glucose, and the resistant. And so it scored 100 on training. It scored an 83 on testing. And so, yep, I keep missing those. So overall, I got a 95. That is pretty good. I think that's our leader so far. So watch. Let's save it. Let's go look at our results. Yep, that's our leader. Boom. Awesome. So let's go back. We're going to do the last 2 now. The last 2 are the decision tree and the random forest. So we're going to duplicate this. Get rid of that. We don't need it. And so these ones are interesting. Remember, for these, for the decision tree and the random forest, you do not standardize your data. So watch this. We'll do decision tree first. Okay. So we need to go down and watch. First is the only thing we do differently. You see how we made a warning for ourselves? Don't standardize data for. So watch. We're going to comment this out because we don't want to use it, and we're just going to say standardize. We're not going to do anything to it. We're just going to say it's our regular data, and then we're going to come down here, and we're going to say, okay, we're going to change this to decision tree, and the parameter name is max depth. Think. Let me check my notes. Yep, that's how you spell it, max depth. So that's how many sort of levels there are on the tree. So let's try 2, 3, 4, 5, and maybe 6. Okay, and so there we go. And let's change this guy to be a decision tree. Let's run this. These might take a little longer to compute. But let's see. Dun, 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 dun. Let's see how it did. Okay, so it said the best depth it found was 2. Okay, so that was the best parameter for the decision tree. Did not do that well. This guy scored a 62 on the testing data. Okay, so training data scored a 74. Testing data scored a 63. Here's the confusion matrix. And look, yeah, it did not do so well. It kind of didn't get a lot of them correct for the test. So overall, 71, not our best. Last one, let's save it, is we're going to take this decision tree, we're going to duplicate it, we're going to make a random forest, okay? And we're going to see who's the best. Random forest. Let me get rid of that. Okay, so look, we already have it. Okay, it's not standardized. Good, that's what we want. And then we come down here. Let's just change this to a random forest. And I think the one it's called is number of estimators. Let me check my notes again. Yeah, n estimators. And we're going to try 1, 2, 3, 4, let's see. 2, 3, 4, 5, 6. We'll try a lot. 9, 10. Those will be the number of estimators. Try 11 and 12. This one might take a while to do. And then we're going to need to make sure to change this one to random forest, because that's the one we want to create. All right, let's see it. How it does. I've got a good feeling about this one. Good feeling, hopefully. Alright, so watch. You can always scroll up here and kind of check it out, how it's doing. So the star means it's not done up here, okay? Okay, the best number, so about 10 was the best number of estimators. Okay, so it's calculating it. We got to wait until it calculates all 9 and determines which one's significant, which one's not. Okay. Alright, so it found out only these 3, the age, the BMI, and the leptin were the most important. Training, it got a 96. Testing, it got an 80. So there's how I did on the test. So overall, I got a 91. Nice. So we exit out. We save, as I always forget to. And then we go to results. Let's see who performed the best. So it looks like our highest score goes to the K nearest neighbor, and probably because it was able to draw those squiggly lines, and it did perfect on the training data. Got an 83 on the test, or the testing data, which is the highest we'd seen out of any of them. And then overall 95. Awesome. So that's our winner, and that would be a 95. That is very high quality. Like, that's a great grade. Like, you could make a lot of money selling this to hospitals, because look, 95% of the time it's right. The other 5% you just get doctors to check it. Good work.